In this problem, we're asked to determine the range. All right, so now let's talk about how we find the domain. The domain is determined by the values that cause a denominator to go to 0. Okay, and it's easy to see that x can't equal 1. So the domain is all values but 1. Now, if we can arrange for the y term to be in the denominator, then we can determine what y can't be. So, we know that f of x is the same thing as y, just another way of tagging it as a function. So we rewrite it. Now, what I want to do is this is written y in terms of x because y is isolated. I want to write x in terms of y. In that case, x is isolated. So I cross multiply. Y times x minus 1 equals 2x minus 3. I distribute, gives me xy minus y equals 2x minus 3. Now, again, I want to isolate my x terms. Okay, so this 2x I want to bring over here, and this y I want to bring over to the right side. So in doing that, I have xy minus 2x is equal to y minus 3. Again, I want x as a function of y, so I factor out the x. It's common to y minus 2 is equal to y minus 3. I divide by my y minus 2, and lo and behold, I got my x term isolated, and in doing that, I can easily see that y cannot equal 2. And my range is not asking what y cannot be, but what y can be. So it can be everything but 2, which means it's running from negative infinity to 2, not inclusive, in union with from 2 to positive infinity. And that's how we find our range for that function and functions of that type. Okay? All right. In this section, we're evaluating functions. Okay? So this is 2 times the function evaluated at 3 less 1. So let's just do it in pieces. The function evaluated at 3 means you throw the value of 3 in for x, which says is 3, and 3 squared minus 2. Okay, so of course order of operations says do the squaring first. That's 9 times 3 is 27. Less 2 is 25. Now, what do I want to do? F of 3 is 25 now. So I want twice 25 less 1. So that's 50 less 1, so it's 49. Okay? This is known as a composite function. So I evaluate from the inside out. G of negative 1 simply says go to function g, put in negative 1. If I put in negative 1, I get negative 2 plus 5, which is 3. Okay? Now I want to evaluate f, the outside function, at this value of 3. Sorry about that. Okay? So let's do that. So now we're going to do what is f of 3. Well, f of 3, if I'm not mistaken, was already determined to be, was already over here. Okay? So f of 3 is simply going to be 25. As you can, yes, 25 is I'm sorry. We're going to put 3 back into f. Again, g of negative 1 is negative 2 plus 5, which is 3. And 3 back into function here is the same as what we did down there, so that yields the value of 25. Okay? This is a composite function. What it says is go to function g and replace all the x's with f of x. So you could do it this way. You could say 2 times the f of x plus 5. So that's doing exactly what it says there. Place the f of x in the g. Now, but what is f of x? F of x is, okay, 3x squared minus 2. So I go 2, the quantity 3x squared minus 2 plus 5. I distribute my terms, 6x squared minus 4 plus 5. So it looks like it's going to be 6x squared minus, 6x squared plus 1, right? Okay? G of 5 squared. So G of 5 means 2 times 5, okay, plus 5, which of course would be 15. And then it calls for that, which is 15 right there, being squared for 225. Okay? So, we'll let it, we'll keep it ending at that point, okay? And we'll come back in the next video and solve the rest of the test.